right, let's take a look at the second half of section 6.5. So in the first half, we practiced writing all the trig functions, the sine, the cosine, all that stuff. But what we didn't do was actually use them to do anything. We just wrote them down. Today, we're going to use them to do something. And what we're going to use them to do is solve triangles. So there's like a couple of different things we're going to look at today. We're going to look at solving right triangles. So we'll practice a little bit of that. And then the second thing we're going to look at is, let's see. Yeah, we're going to look at a little bit with coordinates, all right? And then basically how you can figure out which trig functions are positive where. Like sine is positive. Like if you give me an angle and you ask me what the sine of it is, I might not be able to tell you the sine, but I can tell you if it's going to be a positive or a negative answer, right? And that's kind of important to just know whether you're going to get a positive or negative answer. And it's something the calculator can't really help you with. You have to know something. So I'll show you guys that too. All right, so when we're solving a triangle, it means you have to find out all the sides, all the angles. So there's 6 things to find. But a lot of them, or at least half of them, are going to be given to you. If you're solving a right triangle, what does that mean you already know? Yeah, one of the angles is 90. Okay? That's not really helpful. Every problem is going to have a 90. You need 2 other pieces of information. So you could be given either, in addition to the 90, one of the other angles and one of the sides, or both of the sides. Okay? Those are the only 2 cases that could happen. Why do you think you couldn't be given both angles? Why wouldn't that be helpful?
Be able to properly get the measure of the sides. You can find similar triangles, but it will not be a congruent triangle.
Exactly. Right? If I told you, I am thinking of a triangle and the angles are 30 and 60. So all you know is that the angles are 30, 60, and 90. You don't know any of the sides. So it could be a big 30, 60, 90, or it could be a small one. So 2 angles doesn't help. An angle and a side, or 2 sides. Now, a couple of things we can use as we go through this. You can use Pythagorean Theorem. Right, so that will help. And keep in mind that all the angles in a triangle have to add up to how much? They all add up to 180. Specifically in a right triangle, the 2 acute angles have to add up to 90. Now, when we solve triangles, the way we're going to try to do it is we're going to try to avoid using something that we calculate to find something else. Why would you want to do that? Why would you want to avoid using something you find to find something else? Yeah?
Because you could avoid an error.
Yeah, it could be wrong. And if you use something that you found and it's wrong, well, then guess what? Everything else you find is also wrong. So we're going to try to just always use the information that they gave us, not stuff we find. Okay? So keep that in mind. Whenever we're solving a right triangle, you can use any of the 6 trig functions that you want, technically. But the 3 that are easiest to use are sine, cosine, and tangent. Why do you think those 3 are the easiest? Why not the secant, the cosecant, and the cotangent? I mean, you could, yeah?
Because you use those to find the other ones.
All right, we use those to find the other ones. And how about when you're doing calculations? Think of it that way, like with a calculator. Yeah?
It's easier to put them into the calculator.
Why? What's easier about those 3?
They have specific buttons for them.
Yeah, we have buttons for sine, cosine, and tangent. That's pretty much why we stick with those. So we're always going to use one of those 3 in the problem. So you're not going to have to find all 6 like you did yesterday. You're probably going to have to usually end up finding 2 out of the 6 to do the problem. Which 2 depends on what you're given. All right? So let's say you know the opposite and you want the hypotenuse. Well, if the two sides you're working with are opposite and hypotenuse, then you're going to go with sine. Let's say they give you the adjacent, and you want to know the opposite. So opposite and adjacent, you're going to go with tangent. All right? So you got to look at the problem, draw it out, and see what side you know and what side you're trying to find from the perspective of the angle they give you. Okay. So pictures are helpful. Okay, so let's look at an example. So it says we got a right triangle. One angle is 37 degrees, and the hypotenuse is 8. This is an example of the first type. They're giving you a side. They're giving you an angle. Okay, so what did I say you should do first to kind of help you see the relationships a little better in the triangle? Jake? Yeah, let's draw it out. So again, you can draw your right triangle, bless you, facing any way that you want. Just make sure that when you label it, the way we're going to do it, A is across from alpha, B from beta, C is the hypotenuse. All right, so they tell me the hypotenuse is 8. I'll label that. And then it says one of the angles is 37. It doesn't say which one. Doesn't matter which one. So if you put the 37 at the top, or you put it at the bottom, you're going to get the same two answers that I get. You're just going to call them different letters. And what about the legs? What letters do we usually use to label those? A and B. So that's A, that's B. What angle did I just say is across from A? This one's always across from A, this one's always across from B. Yep, alpha's across from A. And beta, I'm not going to name it because I already know it, but beta is 37. So let's write that down in a table. So I'm just making a table of my 3 sides and my 3 angles. Now, the angle across from C is always the right angle, so we don't have to give that one a special name. And we know it's 90. Okay. A and B I don't know. So I put boxes around them because I'm going to find them. C I know is 8. 37 is across from B. That makes it beta in my problem. And alpha, we don't know. Okay. So any questions on the picture or the table I just set up? Now, because we're not going to use anything that we find to find other things, you can find any one of those 3 first. A, B, or alpha. It doesn't matter. I think something there is a little quicker to find than other things. And you can actually find this just using basic arithmetic. You don't need any sine or cosine at all. So what could I find first, Jake?
Alpha.
Yeah, I could get alpha first. And how would I get alpha?
180 minus 90 plus 37.
Yeah, you could do 180 minus 90 minus 37, or you could even just do 90 minus 37. It's the same thing. So that means alpha has to be 53 degrees. Questions on how we got alpha? Okay, now I have a choice. I have to find A and B. I can use either alpha or beta to do it. I can do this problem from either perspective. Which angle is going to be better to use? Beta, because it's smaller? Because it's given. Who cares how big it is? We're just going to type it into a calculator. But it's given, so we know that it's correct. So let's do everything from the perspective of 37. That's where we're standing in this problem. Alec, do you want to do A first or B first?
Let's do A first.
We're going to do A. So, he said we're going to find A first. So I'm going to circle what we want to find. And I'm going to circle what we already know. Now, I've got to figure out which trig function to use. It's either sine, cosine, or tangent. The side that's labeled A, is that opposite, adjacent, or hypotenuse to the 37? Yep. It's adjacent. So we're looking for a trig function with adjacent. And what about 8? Is that opposite or hypotenuse? Hypotenuse. So I'm looking for a trig function that has adjacent and hypotenuse. Is that sine, cosine, or tangent? Cosine. So we're going to set up our equation. Cosine of, and now you type in your angle. All right, write it down. Cosine of 37 equals adjacent over hypotenuse. Adjacent, we don't know, is A. Hypotenuse, we do know, it's 8. Now when we're done, we want to get A by itself. So what would I do in that equation above where I just wrote to get A by itself? Okay. Multiply both sides by 8 times 8 times 8. Now we got to type that in on the calculator and see what we get, but that's our answer. Any questions on that? And remember, the way we pronounce this is 8 times the cosine of 37. Okay? You're not multiplying the cosine in the 37. Okay? Some people think the 37 is next to the word cosine. That means multiply. No, that's just, the 37 is just what you're taking the cosine of. Think of cosine as like a box. You're dropping 37 into the cosine box, and an answer is going to come out. Right? Just like if you did something like this. You don't pronounce that square root times 37. No, it's the square root of 37. Okay. So 8 times cosine of 37. 8 cosine 37. And I got to be careful because if I hit enter, that's going to be wrong. How come? Yep.
You're in radians.
I'm in radians. All these problems are going to be degrees. So if you put it in degrees, it should just stay in degrees unless someone else changes it. So that's 6.389 for A. Okay, 6.389. Now, I have 2 out of 3 of the sides. What could I do to get the third side since it's a right triangle?
Pythagorean Theorem.
I could do Pythagorean Theorem. But there's actually a couple reasons why I would probably not do that here. Anyone have a reason why I want to stay away from Pythagorean Theorem? Shai?
Because you don't want to use what you got.
Why?
Because
I like what I got. It's a nice number. Why don't I want to use it?
you need to take what's given, not what you got.
Why?
Because it's a law.
All right, and I agree with you, but I haven't really heard a convincing reason why. I like the number 9, and my answer has a 9 in it, so I'm going with that. Sam?
The answer you found is rounded, so it won't give you an exact answer.
All right, so that's one reason. That answer, 6.389, is rounded. So if you use something that's rounded, and then you type it in, and you round it again, you're getting worse and worse accuracy every time. So that answer is rounded. And what else could be a reason? Yep.
You could be wrong.
Yeah, that answer could just be totally wrong. And if it's wrong, then B is going to be wrong as well. So once you get B, if you want to check your answer with Pythagorean Theorem, that might be a good way to check it. But don't use Pythagorean Theorem to get B. Okay? So let's get B the same way we found A. This time I'll circle everything in red. So I'm sticking with the angle that was given. I'm going to stick with the side that was given. And this time I want to find b. So what trig function would I use this time? Wouldn't be cosine. That's what we used last time. It's either sine or tangent. Heard sine? Any other thoughts? Emily, what were you going to say? Sine, yeah, because you want to know the opposite. You know the hypotenuse. Opposite of hypotenuse is sine. Okay, so let's write that down. So we're finding b. Sine of, what am I putting in there? Sine of what?
37.
Yep, sine of 37 equals opposite over hypotenuse, b over a. So you only had to find 2 trig functions. You didn't have to find all 6 like in the homework. But you don't know which 2 you're going to have to find. Okay. Same deal, we're going to get b by itself. And it's exactly the same steps as the last problem, times 8 on each side. And there's your answer for b, 8 sine 37. So you should get about 4.815. Now, I didn't use Pythagorean Theorem at all. But what I'm going to do is I'm going to check my answer. I'm going to do 6.389 squared plus 4.815 squared. And a squared plus b squared should equal what?
C squared.
C squared. And in this case, c squared is how much?
64.
It should come out to 64. I got 64.0035. So is one of my answers off? Like what's going on? Yeah.
Because you rounded.
Yeah, it's because I rounded. But I mean, basically, a squared plus b squared, it does equal 64. So that's a good way to check it and know that we did it right. So you can check that. The other thing you can check is the smallest side should always be across from the smallest angle. Biggest side, biggest angle. Okay. Check that. If something weird happens there, like the biggest side is across from the smallest angle, maybe you wrote something in the wrong spot, or you did something wrong. And the other thing you can check is in a triangle, any 2 sides added together have to be bigger than the third. So like if you add 6 and 4, that's bigger than 8. If you add 8 and 4, that's bigger than 6. 6 plus 8, I'm just rounding, 6 plus 8 is bigger than 4. So any 2 sides added together have to be bigger than the third. If you get sides in a triangle of something like this, that's impossible. You could never have a 1, a 2, and a 10. Because if you add these 2 sides together, it's not bigger than the third. So if that kind of thing comes up, that tells you something went wrong. Okay. So there's our triangle. Any questions? 1, 1, and 2? No, that's impossible as well. Any 2 sides added together have to be bigger than the third, but not equal. Yeah. If you tried to draw a triangle with sides 1, 1, and 2, the sides wouldn't connect right. Either what could happen is you might have something like this, where it doesn't reach, or it's too long to reach, or it's bigger than it should be, something like that. Okay, so that's the type where they start you off with a side and an angle. Now, I had another one with a side and an angle. It's pretty much the same type. Does anyone want to see another one of that type? All right, maybe just start it off a little bit. I won't go through the whole thing. Let's just set it up. Where are these alpha and a? What's the relationship between alpha and a in a triangle? They're opposite. So put a, don't put it as the hypotenuse, but put it anywhere else you want. Let's put a over here. A, and then alpha is opposite. So that means this is B, that means that's beta, and that's C. Okay. I'm not even going to write the right angle because it's always 90. How much would beta be in this problem? Yep, beta would be 70. Alpha, oh wait a minute, did I write the wrong? No, I just know alpha is 20. I didn't write that down. Sorry. And let's see, A is 12.3. So if you were going to find B, I would circle the angle I'm going to use, circle the side I'm going to use, and circle that. And I would say for B, I'm using tangent. Opposite, adjacent. Adjacent is what I want to know. Opposite is what I already know. So I would use tangent. I'll do that one and then we'll stop just because it's a little different. So to find B, you've got tangent of 20 equals opposite over adjacent. Look what's different about the right-hand side. There's your opposite, 12.3. Here's your adjacent. What's different about the right-hand side in that equation compared to the right-hand side when we found A here and when we found B? Something's different. Yeah, the number is in the top and the variable is in the bottom. So to solve this one, it has 2 steps. Okay? After you learn the 2 steps, you can actually do it in 1 step with a shortcut, but I'll show it to you in 2 steps. Let's first put the B on the other side. Okay? How would you do that? Oh, Greta?
Multiply both sides by b.
Yeah, multiply both sides by b and times b. Now, I'm going to circle what we had originally so we don't get confused. That was the original problem. Okay, I'm going to come back to what I just circled in a second. So I have b times some number, which I don't know what it is, but it's something, equals 12.3. Now, how would you put tangent of 20 on the other side? Okay. Yeah, divide by it. When the variable is in the bottom, that's the 2 steps you can do. But I think you'll see a shortcut. So B is 12.3 over tangent of 20. Look at what you started with and look at what you ended up with. Does anybody see a faster way to do that without going through the step in the middle every time? It's more of just like a visual thing. It's not even like arithmetic. Yeah, just switch the b and the tan. Just take what's in the bottom, take what's over here, and have them switch places. Okay. If you don't want to do that shortcut, you don't have to, but that's what ends up happening every time. When there's a variable in the bottom, just switch places with what's on the other side. Could be a tan, could be a sine, could be anything. And then you type that in, and that would be your answer for B. Okay? And then C, I'll leave that for you to finish up, but it's going to be kind of the same steps we did for B. All right, so let's look at this one. This is the case where you're given 2 sides. Now, they say the hypotenuse and one leg of a right triangle measure 12.7 and 6.1 respectively. How do you know which side there is the hypotenuse?
Side opposite.
It's bigger.
It's bigger, yeah. The hypotenuse, if you give me 2 numbers and you say one of these 2 numbers is the hypotenuse, it's going to be the bigger one. Also, the way they say the word respectively at the end, they told you hypotenuse first and then the leg. They gave you the hypotenuse first and then the leg. So, either way. What they didn't tell me is which leg. Doesn't matter. Just put it as any leg you want. So 12.7, that definitely has to be the hypotenuse. But put the 6.1 anywhere you want. Doesn't matter. Okay, so let's call this side A. That side is C. That means the bottom is B. Kylie, if the bottom is B, what's the angle at the top here? What do we call it? We don't have a number for it.
Beta.
Yep, we're going to call it beta. And if A is over here, Isabel, what are we going to call the angle across from A?
Alpha.
Alpha, yep. There's our diagram. So let's make our table. All right, so A is 6.1. B is, we don't know. And C, 12.7. Okay, alpha, we don't know. Beta, we don't know. Okay, so there's my 3 boxes for what I need to find. Now, what can't you do right away that we were able to do in the last 2 problems? There's something we were able to do really fast, get that one out of the way. We can't do that this time. Yep.
Find alpha or beta.
Yeah, we can't get alpha or beta because we're missing both. So you can't just subtract 1 from 90 this time. But there's something else you can do this time that I'm okay with. But I wasn't okay with it in the last 2 problems. What am I okay if you use this time? Yeah? Yeah, I'm okay if we use that. How come? Because we have 2 sides, everything we plug into the Pythagorean Theorem is given. All right? So it's okay to use it. So a squared plus b squared equals c squared. A squared, b squared, c squared. All right. So I need a calculator for that. Or can someone just tell me what's 6.1 squared? It's probably like 36 something. 37.21. All right, plus b squared. And now 12.7 squared, it's probably 160 something. 161.29. All right. Now I need to bring 37.21 to the other side, so we're going to subtract it. So I need 161.29 minus 37.21. 124.08. All right. Now, is b 124? No, that's b squared. So let's find b by taking the square root. So it's probably about 11, a little over 11. 11.139. And that's approximate. Up to that point, it was exact. Now I just rounded it. Okay. Any questions on how we got B? Okay, so we've got B. Now forget about it. You're not going to use it to do anything else. Okay. We can now find alpha and beta. Doesn't matter which one we do. Okay, let's do alpha. Okay, so find alpha. So I'm going to circle what we're going to use. I'm going to use what was given. I'm going to use the other thing that was given, just like we always do. Circle the 2 givens and circle the one thing you're trying to find. So now we have to figure out if we're supposed to use sine, cosine, or tangent. What's the name of the 6.1? It's opposite. Remember, everything is from the perspective of alpha for now, while we're finding alpha. So opposite, and the 12.7, hypotenuse, which means we use sine. Sine of, what's my angle? Alpha, I don't know my angle. That's what's different. This time the variable is, think of it as being protected by a trig function. It's not over on the other side by itself in the fraction. It's in the trig function. So we have sine of alpha equals opposite over hypotenuse. 6.1 over 12.7. So that's a little different. We've never had the variable in the trig function. So to get the variable by itself, we've got to get rid of that trig function. Now, you can't just say, well, divide by sine. When you have a function, you know, like, let's just do something like this. Like squared. The only way you can get rid of squaring something is not with adding, subtracting, multiplying, or dividing. It's another function that's the opposite of squaring. So what's the opposite of squaring? Square what? Yeah, square root. So square root cancels out the squaring functions. They are inverses. Well, let's take a look at how we would cancel out the sine function. So right now, we chose to do sine, which is fine. We have the sine of, what was our angle? Alpha? Yep. So sine of alpha equals 6.1 over 12.7. So we need to cancel out sine. How do you cancel out sine? You do the opposite of sine. Okay? And what that's called is inverse trig. Okay? Specifically, we're going to use inverse sine. So I guess you could almost say, like, if you said, how do you get rid of squaring? You could say the inverse of squaring. But we have a name for that. We call it square rooting. How do you get rid of sine? Inverse sine. That is the name. Okay, that's what you use. So, inverse trig functions, first of all, are written just like that. You've got a trig function and then a number up a little higher. Now, if you think the -1 is an exponent, I can see why you would think it, because it's up higher. And if you put a number there besides a -1, it is an exponent. But when you put a -1 there, it's not. This -1, just think of it as a special symbol. It just means inverse sine. It has nothing to do with a -1 exponent at all. Okay, at all. And now, next to inverse sine, notice I wrote arc sine. So, arc sine, sine with a -1, inverse sine, same thing. It's just like a newer way of writing it, older way of writing it. Same with inverse cosine. Newer way of writing it, older way of writing it. They mean the same thing. And then inverse tangent as well. So, sine and inverse sine basically cancel each other out. And I'll show you an example with numbers, and then we'll do our problem. Let's take the inverse sine of the sine of 15. Now, if inverse sine and regular sine cancel each other out, when I hit enter, what do you think the only thing is there that's going to be left? The 15. Yeah. They wipe each other out. It's kind of like if you did the square root of 9 squared. Well, you just typed in square and square root. They cancel each other out. So all you get back is what you originally typed in. How about inverse sine of the sine of 75? I get 75. All right, so they cancel each other out. All right, so now let's go back to our problem. All right, so I've got sine of alpha equals, and then I got a number on the other side. I don't really care about the number on the other side. What I care about is getting that by itself. So what function can I use to get rid of sine? Inverse sine. Now, when you use a function, like the verb you want to use here is take. Take the inverse sine of what's on the left. We are not multiplying. You can't multiply by words. You multiply by numbers and letters, not words. So take the inverse sine of what's on the left. I don't really have a ton of space here. Take the inverse sine of what's on the right. Inverse sine, regular sine cancel each other out, just like they did right here. So what you're left with is what I'm pointing to by itself. And now how do you figure it out? Well, we type it in. To get to an inverse trig function, you have to press second. That's how you do it. Second, and then your trig function. So second sine, 6.1 over 12.7. And that's your answer. Okay, so I'm not going to go through all that explanation about inverse trig every time. Now when we see a problem and we need to use it, we'll just do it on both sides. So 28.706. What is that one? That is alpha. Now, if I was running out of time and I had no other option to solve this problem, technically I could just subtract that from 90. Right? That's what it should be. So it should be about 61.294. Okay, keep that number in mind for a second. 61.294. I'm going to find beta the same way I just found alpha. Okay? If I do it this way, I'm hoping I got alpha correct, because if I just got alpha wrong, then guess what? I just got this wrong too. So let's find beta the same way and see if we get 61.294. All right, so let me circle one thing we're going to use, the other thing, and that. Now, from the perspective of beta, what's the side that's 6.1 units? Opposite, adjacent, hypotenuse? It's adjacent. That's adjacent. The other thing is hypotenuse. Trig function I use with adjacent and hypotenuse is cosine. Let's find beta. Cosine of beta equals adjacent over hypotenuse. Now, we ended up again with a variable right next to a trig function. It's inside the trig. How do you get rid of cosine? Take the inverse cosine. Yep. Take the inverse cosine of what's on the left. Don't forget to do it on the right. And when I do inverse cosine, hopefully I get 61.294. Let's see. Inverse cosine, 6.1 over 12.7, and I get 61.294. So since I got the exact same answer doing it two different ways, it's pretty much guaranteed I did it correctly.
Hello.
That was weird. 61.294. Okay, so that's solving a problem with two sides. So out of the two types, you only have to use inverse trig if you want to find an angle. That's important. Inverse trig is used to find an angle. Okay, just like Pythagorean theorem is used to find sides. Inverse trig is used to find an angle. If you don't need to find an angle, you don't need to use inverse trig. We already went through all that. Okay, so I'm not going to go through this one. But if I did, would this be a problem where I use inverse trig? Yes. I need to find angles. I can use Pythagorean theorem to get a side, but I would have to use inverse trig to get an angle. All right, so last thing we're going to look at, and this is actually a little easier than what we just did. It's kind of like finding the 6 trig functions, which we've already done before. But let's make a sketch and just make sure I remember how to do it. So it says the point 2,3 is on the terminal side of an angle. Now, don't worry about the angle. They're not asking you for the angle. They just want to know the trig function. So it's like what you did yesterday again. Sine, cosine, tangent, secant, cosecant, cotangent. All right. The point 2,3 is on the terminal side of the angle. 2, 3. That means the terminal side of the angle, it's not perfect, but it's about like that. Initial side is always on the x-axis. Okay, so let's take this and go like this. I basically just made a triangle. I'm moving it off to the side so I have more room to draw it. There's theta right there. How long is the bottom side in that triangle? 2. How tall is it? 3. And now to find the 6 trig functions, I'm missing one of the sides. How can I get the last side? Pythagorean Theorem. 9 plus 4 is how much? 13. And there's your hypotenuse. Okay. So let's start with the sine. Connor, what would the sine be here?
For theta, the sine would be the opposite hypotenuse, so 3 over the square root of 13.
So he said 3 over the square root of 13, and I fixed it so the root wasn't in the bottom. 3 root 13 over 13. Rebecca, how about the cosine? 2 over the square root of 13. And then when you fix that one so the root's not in the bottom, what would you have?
I have no idea. I honestly don't know that.
How would you, Connor, can you explain how to fix that?
You would have to multiply it by square root of 13 over the square root of 13.
Yep. Multiply the top and the bottom by the square root of 13. In the bottom, it cancels out. And then in the top, you just write it the way you see it. 2 times square root of 13. That's it for that. Kylie, how about my tangent?
That would be 3 over 2.
Yep. And now cotangent, that one's pretty easy because we flip it and there's no root, 2 over 3. And now the other ones, to flip them, I would go back to what we had originally. So Connor said that this was 3 over the square root of 13. Flip it, square root of 13 over 3. It's okay if you flip this one, but the root goes back to the bottom and then you got to fix it all over again. To do cosine, I'll take what Rebecca said originally, 2 over the square root of 13, and flip it. That's kind of a review problem, just doing all the same stuff we did yesterday. But what I want you to kind of notice, which quadrant is theta in there? It's in the first. Did the sine come out positive or negative? Did the cosine come out positive or negative? And the tangent? Positive. In quadrant 1, every trig function always comes out positive. And I'm going to give you a diagram for how to remember that. Okay. But for now, that's all I want you to notice. You don't have to write that down yet. I will at the end. All right, let's solve for the angle in example 3. So now I want to know what the angle is. We have 6 equations. You could use any single one of those to solve. I would definitely stick with one of these 3 because you're going to have to use inverse trig and you've got buttons for those. Which one would I do? I usually just do the first one, sine of theta. Okay. Let's copy it down. And I'm going to copy it the way Connor said it originally, 3 over the square root of 13. I'm okay with that because that's not a final answer. We're going to use it to get a final answer. And honestly, that is less for me to type in the calculator than that. That's 2 things. That's 3 numbers. Okay, so that's easier to type in. How am I going to get rid of sine? Inverse sine. So theta is the inverse sine. And again, square root in the bottom is okay because that's not the final answer. This is the final answer. Inverse sine, 3 over square root of 13. That angle is about 56.31 degrees. Now, let's say you said, you know what, I don't want to use inverse sine. You did inverse cosine. Or, you know what, inverse tangent's easier to type in. Let's take the inverse tangent of 1.5, 3 over 2. Let's see what I got. Inverse tangent of 3 over 2, 56.3, I get the same thing. So what I'm trying to show you is when you want to solve for the angle, it doesn't matter which trig function you use. If you've written them correctly, they all work. Which one do I think is the best one to use? Inverse sine. There's reasons why. Okay, I would stick with that one. Right? And if you did inverse cosine, you'd get 56.31 again. So when we solved for that angle, it was in quadrant 1. We already knew that by looking at the picture. So it's one step. 56.3 degrees, you're done. But if it's in quadrants 2, 3, or 4, you're not done. You have to do a little arithmetic. You have to add or subtract something. Okay, and I'll show you why. So the first thing you want to do is what I suggested. Find the inverse sine and take the absolute value of it. Okay, what we're finding here is called a reference angle. So you take the inverse sine and just make sure that it's positive. When you hit enter on your calculator, if you get a negative answer, you just ignore it for what we're doing right now. Now, let's pretend that you had a point in quadrant 2. Put a point somewhere in the second quadrant. Where I just drew theta, that's called your reference angle. The reference angle is always tucked between the hypotenuse and the x-axis. I want to know what that arc is in black, from here all the way to here. If you knew theta, how could you get the part outside the triangle if you knew the little part inside? Just a little bit of arithmetic, something minus something. Yep?
180 minus theta.
Exactly. So if you're in quadrant 2, it's 180 minus what you got for your reference angle, which we call theta. If you're doing it in radians, it's pi. Degrees, it's 180 minus. Now, let's look at quadrant 3. Let's put a point somewhere down in the third quadrant. Let's put our reference angle. Reference angle, always tucked between the hypotenuse and the x-axis. Now, what if I wanted to know that arc in black? I got to do a little bit of arithmetic. Kind of like the last one, but a little different. Sam?
Would it be 180 plus the angle?
Yeah. You've gone halfway to this point, and then you've gone a little bit more. So it's 180 plus the angle. So if you have to get an answer in quadrant 3, that's how you do it. 180 plus your angle. You probably could figure it out just by drawing these pictures and kind of thinking it through, but if you want to write them down, that's why I have them over there. Now, let's do this one. Let's say you had a coordinate in the fourth quadrant. Make a triangle. There's your reference angle. Again, right between the x-axis and the hypotenuse. This time, I want to know that. How would I get that one? Yep.
270 plus the reference angle?
If you knew this part, yes. That would be 270 plus this part right here. But we don't know the part on the outside. We know the part on the inside. But otherwise, that would have worked. Yep?
360 minus theta.
Yes. It's 360. So you go all the way around, and then you subtract out this little part, and that leaves you with what you have left. So that's how you find an answer depending on the quadrant. Okay, so do the inverse sine first, make it positive, and then follow what the formula says. Okay, so let's try the same thing. It's pretty much the same coordinate. So we should already know what inverse sine is going to come out to, because we just did it. Well, 56.3, I think it was somewhere. All right, but let's just go through it, pretend that we don't know. Okay, so I make a quick sketch. 2, -3. What quadrant is 2, -3 in? 4. Right 2, down 3. I'm not really concerned about an accurate sketch, just roughly where it would be. In fact, you don't even really need to make a sketch if you can visualize it in your head. But if not, here's your sketch. This side's 2. That side is 3, but it's down. That's why it's negative. All right, and reference angle is tucked in right between your x-axis and hypotenuse. Bless you. Okay, so try to remember that. You always look at everything from the perspective of the angle near the origin. Never from the angle that's way out here. Never. Always from the one that's really, really close to the origin. All right. We're going to have to do inverse sine. Sine involves hypotenuse. We just found the hypotenuse of this triangle last time. It was 13. Square root of 13. Okay, so let's find the reference angle. It says to do the absolute value of the inverse sine. All right. So do the inverse sine. What side is opposite? 3. What side is the hypotenuse? Okay. Again, we just went through all this. In fact, I still have the answer right here. I'm not even going to type it in again. Inverse sine of 3 over the square root of 13 is 56.31. Now, let's say you said, well, wait a minute, isn't that technically a -3? Well, it doesn't really matter if you do it as a negative, because watch what happens. Let me put it in as a negative, and I'll show you. I got negative 56.31, but what am I supposed to do to that answer anyway? I'm supposed to take the absolute value, so it really doesn't matter if you use the negative or not. If you want to use the negative and just take the absolute value after, just do it that way. Okay, but your reference angle is 56.31 degrees. Now, what quadrant are we in? Yep, we're in the 4th quadrant. So the answer to this problem, we're trying to find this angle right here. It's going to be 360 minus 56.31. So the answer, no. 360 minus 56.31. So the answer to the problem is 303.69 degrees. That's what they're looking for. Okay, so it's not that much harder when it's in another quadrant. You just got to find the reference angle first, and then add it or subtract it from 180 or 360. Okay, any question on that one? So last thing, if you end up with, if you end up working with 0, 90, 180, or 270, those are like special cases. The reason they're special cases is because they're all on an axis. Anytime you've got a coordinate on an axis, it always has what number in it?
0.
It always has a 0 in it. Right? So like if you wanted me to do something with 90 degrees, 90 degrees is right there. It's just straight up. Well, you don't go left and right to get to 90. How far up do you go? I always think of it the way we did it on a unit circle. The coordinate for 90 is 0, 1. Over here is -1, 0. Over here is 0, -1. And over here is 1, 0. And when I think of these, it's kind of weird because you don't really have a triangle. It's not like I got a point over here and I can make a triangle out of it. It's right on the axis. So when it's on the axis, it's easier to think about it like this. Sine is y, cosine is x, tangent is y over x. That's how we did it when we did unit circle trig. That's how I would do it for these points. Opposite and adjacent and hypotenuse don't make sense. Because you don't really have a triangle, so you don't have a hypotenuse. Okay? That's only when it's on an axis. All right. Secant is 1 over x, cotangent x over y. Those are all old formulas, I think, from section 6.2, maybe 6.3. So like if you said, all right, what's the sine of 90? I'd say, okay, here's the coordinate. Sine is the y value. The sine of 90 is 1. What's the cosine of 90? Cosine is the x. X value is 0. What's the tangent of 90? I need the y divided by the x. 1 divided by 0. I can't divide by 0. Tangent of 90, undefined. Right. How about, what if I said, what's the sine of 270? What would that one be?
-1.
Yeah. Sine is the y value. There's your coordinate for 270. Y value is -1. All right, so last thing I told you I'd give you is a diagram that shows you where the trig functions are positive and negative. In quadrant 1, the sine, the cosine, and the tangent all came out what?
Positive.
All came out positive. That's why in quadrant 1, I had the same thing written twice. It's weird. In quadrant 1, all of the trig functions are positive. In quadrant 2, in other words, if you give me an angle between 90 and 180, 104, if I start taking trig functions of 104 degrees, there's only one that's going to come out positive, and that's the sine. I'll show you. The sine comes out positive. If you take the cosine, it comes out negative. And if you take the tangent, it comes out negative. So the only trig function that's positive in quadrant 2 is sine. Quadrant 3, the only positive one is tangent. So if you have a number between 180 and 270, and you start doing some trig with it, the tangent will come out positive, nothing else. Quadrant 4, it's the cosine. So pick a number between 270 and 360. And the only trig function that will come out positive is cosine. So ASTC. That's how you can remember which trig functions are positive where. We're not going to do a ton with that knowledge right now, but knowing where trig functions are positive, much more important later in chapter 7. Any questions on that? All right, so the homework tonight, same area as last night, still page 360, 361. Might go on to 362, I'm not sure. But it's 25 to 32, 40 to 42, 45, 49, 53, 57, 61. So we'll take a look at that tomorrow. This finishes chapter 6, which was our first chapter on trig.